Hi students, in this video we're going to look at how to solve exponential equations using logarithms. Alright, so the key learning goal for this video, as you might have guessed, is just to solve exponential equations using logarithms. Alright, so some things to recall before learning this skill. First of all, remember the definitions of logarithms and exponential equations. Remember your rearranging skills, so being able to use BOMDAS in reverse, and also using inverse operations. And finally, and this is a very important step, being able to remember log law 3. That is, log a to the x is the same as x times log a, where that power comes to the front. Alright, so log law 3 is really useful in solving exponential equations because it moves x, or our unknown, from the power down to the front of our term, becoming a coefficient. So once we've got x from that power to a coefficient, it's quite easy to rearrange from there. So our steps for solving an exponential equation using logarithms. First of all, we want to use our normal rearranging rules, BOMDAS in reverse, inverse operations, to rearrange our equation so that we have it of the form something to the power of x or something to some unknown power. It could be an expression, x minus 1, or just x on its own, whatever it is, doesn't really matter, as long as you've got your equation down to a form base to some power involving an unknown equals some value. After that, you can apply logs to both sides, and from there, and this is the key step, apply log law 3. Bring that power down to the front of our expression, and then from there it's a simple rearrange to get x. Alright, so let's do some examples. Solve the following exponential equations using logs. 2 to the x equals 32. So for this first one, that first step's already done. We've already got our base to some unknown power equals our value 32. So we can just apply logs to both sides. So log 2 to the x equals log 32. And then from there, we can use our third index law that says that power up there can then go to the front, so that our equation is now x log 2 equals log 32. Now remember, there is a multiplication in here, so it's x times log 2 equals log 32. So to rearrange this equation, we can just divide both sides by log 2. So x equals log 32 over log 2, which equals 5. When you put it into your calculator. Let's just remember that when we're using log here, we don't have a number at the bottom. That just means we're using, or it's assumed that we're using, log base 10. Alright, let's do this second one. So this time we haven't got it fully rearranged yet. We want to get 1.4 to the x on its own. So we'll just rearrange that one just like we would with our normal rearranging rules. So 5 times 1.4 to the x equals 15, and then divide by 5, 1.4 to the x equals 3. Now students, there can be all sorts of mistakes made with this one. Some people might think we should do 5 times 1.4. We can't do that. That's not how BOMDAS, that's not how powers work. We need to deal with the multiplication first, and then we can touch the 1.4 and the power after that. So please do not multiply 5 by 1.4. That's not on. From here we can just solve using the same steps as above. So log both sides equals log base 10, 3. X can come to the front, so x log 1.4 equals log 3. Rearranging, x equals log 3 divided by log 1.4, which equals to two decimal places, 3.27. Alright, our last example, definitely a complex example. We've got 3 to the x plus 1 equals 5 to the 4x minus 4 minus x. Alright, so our first step again is just log both sides. We've already got our equation where we've got one exponential term on one side and one exponential term on the other. So logging both sides, log 3x plus 1 equals log 5, 4 minus x. Bringing those powers to the front, x plus 1, I'm just going to include that in brackets there because the whole power is coming to the front, equals 4 minus x log 5. Now students, my advice here for this one is make sure you put that power in brackets when you bring it to the front. You don't want to miss those brackets and think that you're actually working with 4 minus x log 5. Okay, that is not right. The brackets need to go there so that we can actually just expand those terms and help us solve here. Okay, so we're getting rid of that. Okay. With these brackets, we're going to expand them to get x out, to get rid of those brackets, and then just collect some like terms. So we'll have x log 3 plus log 3 equals 4 log 5 minus x log 5. Rearranging that, x log 3 plus x log 5 equals 4 log 5 minus log 3. So just moving all my unknowns to one side and all my constants to the other. That left-hand side we can factorize. So x log 3, or x out the front, of log 3 plus log 5, which actually equals x log 15. Using our log laws, adding our logs means we can multiply our values. So that left-hand side then equals 4 log 5 minus log 3. Last step, rearrange for x, 4 log 5 minus log 3 over log 15 equals to 2 decimal places 1.97. So a bit more involved in that example, but the same sort of steps apply as you would any sort of algebraic equation, just this time involving some expanding and collecting like terms, bit of factorizing to help get x back on its own. Alright, so after watching this video, you should be able to solve exponential equations using logarithms.